Hello, everyone, and welcome. I'm excited to have you here today. We're going to demystify networking protocols and standards, a fascinating topic that underpins how our digital world functions. The title of today's presentation is Demystifying Networking Protocols and Standards. We'll be covering key protocols like HTTP, TCP, UDP, IP, and many others, helping you understand how they work together to keep our networks running smoothly. So, let's dive in and explore the essentials of networking protocols and standards. Let's talk about why protocols really matter in the world of device communication. Think of protocols as the set of rules that devices follow to understand each other. Without these rules, devices wouldn't be able to exchange information effectively or securely. They help ensure that communication is reliable, meaning the data gets where it needs to go without errors. They also contribute to speed, making sure information is transmitted quickly. And of course, security is a big part of it, protecting sensitive data from unauthorized access. In this presentation, we'll look at 13 key protocols and explore their specific use cases, so you can see how these rules are applied in real-world scenarios. And just a quick note, these images are licensed to give credit to the creators, so I want to acknowledge that. Understanding these protocols is essential because they form the backbone of how our devices connect and communicate seamlessly, which ties directly into the overall theme of building a connected, efficient digital world. All right, let's talk about the transport layer, focusing on TCP and UDP. First up, TCP, or Transmission Control Protocol. It's known for being reliable and ensuring that data arrives in the correct order. That's why it's commonly used for activities like browsing the web, sending emails, or transferring files, where accuracy is critical. On the other hand, we have UDP, or User Datagram Protocol. It's much faster and lighter weight, meaning it has less overhead. Because of that, it's ideal for real-time applications like streaming videos, online gaming, or VoIP calls, where a bit of data loss is acceptable but speed is essential. So the key takeaway here is that TCP prioritizes reliability and order, while UDP emphasizes speed and efficiency. Both are crucial, depending on what the application needs. And understanding these differences helps us see how the transport layer supports different types of internet activities seamlessly. Let's take a closer look at the network layer, specifically focusing on IP and IPX. When we talk about IP, or Internet Protocol, we're referring mainly to IP4 and IP6. IP4 has been the foundation of global networking for decades, routing packets across networks around the world. But as the internet grew, we needed a more scalable solution, which is where IP6 comes in. IP6 not only expands the address space, but also future-proofs our networks by supporting the increasing number of connected devices. Now, moving on to IPX. This was originally used in legacy Nova LAN environments for routing within local networks. However, IPX is now considered obsolete. It's a good example of how network protocols evolve over time, replacing older standards with more efficient, flexible options. Connecting this to the bigger picture, understanding these protocols helps us see how network layers adapt to meet the demands of modern communication. IP4 and IP6 keep us connected globally, while knowing about IPX gives us historical context for how network routing has developed. Let's talk about the application layer, specifically HTTP. HTTP is really the foundation of the web as we know it. It's what allows us to access websites, send and receive data, and interact with online services. When we add security through HTTPS, it's like putting a protective shield around that communication, making sure our data stays private and secure. HTTP is used in a variety of ways, primarily for websites, but also for APIs and apps that need to exchange data over the internet. Think of it as the language that browsers and servers speak to each other behind the scenes. And just a quick note about the image here. It's licensed under CC BY NCND, which is a reminder that many of the visuals we use are shared openly, just like the open nature of HTTP itself. Overall, Understanding HTTP is key to grasping how the web functions smoothly and securely for everyone. Let's take a closer look at some common discovery protocols that help devices communicate and organize themselves on a network. First up is UPnP, or Universal Plug and Play. This protocol is really handy for auto-configuring devices like smart TVs and IoT gadgets. It allows them to discover each other and set up connections without us having to do much manual work. Next is DNS, the Domain Name System. Many of us use it every day. It's what translates human-friendly domain names like www, example, com into IP addresses that computers understand. This process is crucial for browsing the web smoothly. Then there's DHCP, which stands for Dynamic Host Configuration Protocol. Its job is to automatically assign IP addresses to devices as they join the network. This way, devices can communicate without us having to manually set their IPs, making network management much easier. All these protocols play a vital role in ensuring devices can find each other and function seamlessly within a network. They form the backbone of device discovery and configuration, which is essential for maintaining efficient and user-friendly connectivity. Today, I want to talk about diagnostics, specifically focusing on ICMP, which stands for Internet Control Message Protocol. ICMP plays a crucial role in network diagnostics because it helps us identify and troubleshoot connectivity issues. One of the most common tools that uses ICMP is the ping command. When you ping a device, you're essentially sending an ICMP echo request to that device and waiting for an echo reply. This simple exchange allows us to check if the target device is reachable and how long it takes for messages to travel back and forth, giving us valuable information about network latency and packet loss. Another important aspect of ICMP is its role in reporting errors. For example, if a router cannot deliver a packet to its destination, it can send back an ICMP message indicating what went wrong. This feedback is vital for diagnosing where the problem might be occurring along the path. Connecting this to our overall theme, understanding ICMP and how to use its diagnostic tools enables us to maintain a healthy, efficient network. It allows us to quickly identify issues, whether they're related to reachability, delays, or routing problems, so we can address them promptly. Let's take a closer look at file transfer protocols, specifically FTP and PPPoE. FTP, or File Transfer Protocol, is a standard network protocol used to transfer files between a client and a server over a network. It's widely used because of its simplicity and efficiency in managing large data transfers. PPPoE, which stands for Point-to-Point Protocol over Ethernet, is a bit different. It's commonly used to establish a direct connection between two network nodes, often for broadband internet connections like DSL. Both of these protocols play crucial roles in how data moves across networks. FTP ensures that files can be uploaded and downloaded securely and reliably, which is essential for many applications. Meanwhile, PPPoE helps manage the connection setup and authentication for internet access, making it a key component in the overall network infrastructure. Connecting this to our broader theme, understanding these protocols helps us appreciate the underlying mechanisms that keep our data flowing smoothly and securely across various network environments. Let's take a moment to look at security and email, focusing on NAT and SMTP. These are critical components in safeguarding our email communications and ensuring smooth network operations. NAT, or Network Address Translation, plays a key role in hiding internal IP addresses from the outside world, adding a layer of security by making it harder for attackers to target specific devices. It also helps us conserve public IP addresses, which is always a plus. Now, SMTP, or Simple Mail Transfer Protocol, is the backbone of email transmission. It's how emails are sent from our devices to mail servers and then relayed to the recipient's server. When we talk about security here, we emphasize the importance of securing SMTP connections, often through encryption protocols like TLS, to prevent eavesdropping or tampering during transmission. Connecting this to our overall theme, understanding how NAT and SMTP work together helps us appreciate the balance between making our email systems accessible and keeping them secure from potential threats. It's about creating a robust environment where our communications are both reliable and protected. When considering when to use each protocol, it's important to understand their specific roles in network communication. For example, HTTP is primarily used for websites and APIs, making it essential for web browsing and data exchange on the internet. TCP, on the other hand, is reliable and is used for emails and file transfers, where accuracy matters. UDP is faster but less reliable, making it ideal for streaming media and online gaming where speed is more critical than perfect delivery. IP acts as the backbone, handling all internet traffic by routing data packets across networks. Moving to more specialized protocols, IPX was used in legacy novel networks, but it's mostly obsolete today. UPnP is designed for home IoT devices, enabling easy device discovery and communication within smart homes. DNS is crucial for resolving URLs into IP addresses, allowing us to access websites using human-readable addresses. DHCP manages dynamic IP address assignment in LANs, simplifying network configuration. ICMP is used mainly for troubleshooting, like ping tests to check connectivity. FTP is a protocol for transferring files to and from servers, often used for website maintenance and data sharing. PPPoE connects users to their internet service providers over DSL connections. NAT is vital in routers, translating private IPs to public IPs for internet access, which also adds a layer of security. SMTP handles email sending between servers, completing the email communication process. Connecting all these protocols helps us understand the complex ecosystem of the internet. Each one has a specific purpose, and together, they enable smooth, efficient, and reliable network operations. Recognizing when and why to use each protocol is essential for designing and maintaining effective networks. Now, let's wrap things up with some key takeaways. First, it's really important to understand the core concepts we've discussed today because they form the foundation for everything else. Remember, the most significant point is how these ideas connect to the bigger picture. They're not just isolated facts, but part of a larger story about growth and innovation. As we move forward, keep in mind how these principles can be applied practically in your work. Ultimately, staying focused on these key points will help you make more informed decisions and drive better results. Thanks for staying engaged through this presentation. Questions and sources. Got questions? Feel free to drop them below. I'm happy to clarify any points or dive deeper into any topics we've covered today. And just a quick note on sources. This presentation is based on reputable materials like IETF RFCs, Cisco Guides, and TechSpot. These resources help ensure that the information I shared is accurate and up-to-date. Remember, understanding these foundational concepts is key to grasping the bigger picture of network communication and security. So, don't hesitate to ask if anything's unclear or if you want to explore a specific area further. Thanks for your attention.